For on today's session is on early fatigue life predictions in the design stage using the Simsolid, right? Before going to how and you can perform the fatigue simulation using the Simsolid, so let us see what is the importance of fatigue life in the early design phase, right? So, what is the importance of fatigue evaluations in the design stage? So, actually, it helps in identifying the critical areas, which allows for the necessary design modification that will prevent the failure, right, during the operational life. So, it also helps to make iterative design improvements to extend the operational life. So, if we talk on the benefit side, it is cost effective if we realize the failures before, right? So, in addition to this, if we see the example of like the fatigue strength of thin plates, especially in the large structures. So, most of the times, the failure we can say mainly maybe because of influence of weld geometry and also of material. Okay. So, as we know, what is the importance of fatigue? So, let us see what is the fatigue. So fatigue is a progressive and localized structural damage which can be seen on when a material is subjected to repetitive loads or the cyclic loading, right? So what are the different approaches we have to evaluate the fatigue phenomena? So we have high cycle fatigue, which is also known as stress life method, and also we have low cycle fatigue approach, which is strain life method, right? In both the approaches, we have these two types like uniaxial and multi-axial methods. So in each methods, we have this actually what is this uniaxial approach for solving the fatigue evaluations. In this, the models with uniaxial loadings consist of loading in one direction, so which is resulting in one principal stresses. So what Simsolid does, it converts the stress tensor to scalar value using user-defined combined stress method. So when I say stress method, Gerber, Goodman, Soderbergh, and so on, these methods used for when you're going with the stress life method. With the strain life, SWT, Morrow methods are used under uniaxial approach. So when we go on the multi-axial side, this basically uses a stress tensor directly to calculate the damage. It searches for the most damaged plane, right? By using the damage models. So when I say damage models, we have Goodman for tensile crack damage model and the Findlay for shear crack damage model. This is for the high cycle fatigue approach, whereas SWT model for the low cycle fatigue approach, and the FS model, that is for shear damage models, can be used for the low cycle fatigue. So these are the different evaluation methods we can say where you can choose while evaluating the fatigue inside the Simsolid. You can select which method you want to perform to evaluate your fatigue simulations. Okay, so that we can see while having the demo on the model. So this is on what are the different type of approaches we have under fatigue. So let us see what are the types of fatigue simulations that can be performed inside the Simsolid, right? So we have SN time and EN time, that is stress life and strain life time simulation. In this, it uses load histories to calculate the stress time history. Okay, and then we have SN sequential and EN sequential. In this, actually, it uses the load cases in sequence. Means you need to give the load cases in sequence manner so that it is applied in that sequence only, and it is behaving as if the individual loads are applied in the separate time steps. You know. Then we have SN random and EN random. So this is basically linked to the dynamic run, that is random response analysis. from where it takes the input for the fatigue evaluation. So these are the different types of fatigue simulations which can be performed inside the Simsolid. So let us have a quick demo on some of the methods by using some of the fatigue simulation methods. So today we'll be seeing a demo on automotive chassis model. Okay, so when we say the chassis design evaluation, so which are the most no, I mean performance evaluation simulations? Those are like stiffness evaluation, vibrations, and fatigue. These are the main evaluations we can say which play huge impact if we get to know in the early design phase, right? So today we are not seeing much detail on the stiffness or vibration. For the vibration simulations, yes, you can perform in this using SimSolid, but this we will be seeing on the vibrations simulations in our next session, that is in the next week, that is August 2nd. So in today's session, we'll be concentrating on the fatigue simulations. So for today's fatigue evaluations, so we have already created initial set of load cases, that is stiffness load cases, on which we'll be taking those as a reference for evaluating the fatigue, right? So let us move on for the quick demo. So this is a chassis model where we have already set up the initial set of static load cases. There is bending load cases and torsional load case have already been defined on the chassis model. So we have already run the static simulations on these two load cases. So now we are reviewing the material properties, because as we are going for the fatigue evaluations, we need to see that the fatigue properties also be mentioned, created in the under the material properties, right? So as I'm showing you the SN approach, stress life, so we need to have the SN curves defined under the material properties. So if there are no fatigue properties mentioned under the materials, we can create the curves through the three approaches. One is estimating from UTS, or from one slope or two slope methods, where you can specify the coefficient values of fatigue, and you can update this through the material database. So the same way we can do for the strain life curves also, and even for the seam weld material properties as well. Okay, so once we are done with the material properties updation, now we can set up SN time analysis. This basically uses load histories, right, to for the stress time history calculations. So in this, the first step will be we can import the channel directly. When I say the channel, it is basically we are giving the tabular form of time versus amplitude factor. Okay, so here we have imported the channel in .csv format. It can have a number of curves in the CSV. Okay, so here we have two curves and one uniform curve Simsolid automatically creates on the fly. So once we have created the channels, we can create the event setup where we are linking the channels and load cases, and we can specify the channel scales for each event. And you can also set up the event repeats, how many repeats you want to perform. And then yeah, for fatigue evaluation, you can have n number of time events. Right now I've created only one time event. Okay, so yeah, before going for the solve, we can go to fatigue solution settings, where you can set the fatigue methods, uh, multi-axial or uni-axial, or what are the damage models you want to consider for the fatigue evaluation. Okay, so like in the previous slides, what I've shown the damage models which under the SN and EN approaches. So you can mention under the fatigue solution settings. Okay, so under this, you can also see what are the different materials which have been considered for the assembly, and you can cross-check on the fatigue properties for the assembly. Okay, so here we are reviewing the inputs through the fatigue solution settings. Now we can go for the fatigue evaluation. So the evaluation is done for the SN time. Now, while post-processing, we can check on the fatigue damage and fatigue life. Okay, so while evaluating the fatigue damage, you can check where exactly the max damage, and if you want to see which are the parts mostly affected on the damage side, you can also check that. So the number of parts ranked by damage. So this number is flexible. You can change as required. So you can select maybe the top one or top three like that to check where exactly the damage is happening. Okay, while checking the fatigue results. So this how you can post-process your results for SN time fatigue, where we have considered the load histories, right, which we have defined through the channels. So let us move on to the next type of fatigue simulation, that is SN sequential analysis. So in this, we can automatically import, .csv file, where you will be defining the relation between the load cases in which sequences it has to perform. Okay, this is the where you can import .csv. Okay, or else we can have set up manually the sequences. So I'm setting up manually. So I'm selecting the load cases in a sequential manner, which I need. And I can also set the scale of each load case, and you can start from zero load and how many sequence repeats you want to perform. Okay, so we can have a number of sequences. So I'm creating one more sequence by changing the sequence of load cases, and even the load scales also we can change. And we can give the you can switch on the start from zero load, or you can start directly from the load case. Okay, and also the sequence repeats. So we are set up the SN sequential run. So now we can check the post-process the results. So you can see we are getting the max damage for both the sequences, right? So here you can check either individually on each sequence how the damage where it is occurring, those type of things. And then if you want to check both the sequences, the cumulative damage, so that also you can check by selecting both the sequences. Okay, so here right now the previous one what we saw, it has taken the load histories, right, to calculate the stress time history, whereas in this it is taking the sequential load cases which are applied in different time steps. So here you can see the fatigue life as well for both the sequences. So this is on the two types of fatigue evaluations what we saw till now. So let us move on to the, sorry. So let us move on to the SN random simulation. Sorry. Yeah. So for this, it needs to have random dynamic simulations run before going for the fatigue simulation, right? So for this, I have set up the random response analysis before uh, by giving the PSD functions on it and the base excitation in terms of acceleration. So for that, the random response, since it is based on the model approach, so we are giving the model analysis as a reference for the random response. Then we are defining the PSD function, which is linked to the base excitation function through the acceleration. So that's where we are giving the curve for solving the random response analysis. So from the random response results, the PSD stresses will be taken as an input for further fatigue evaluation. Okay, so here we are just reviewing the results of stresses and the displacements of the dynamic run. So now we can go and set up the SN random simulation. So where you can select what is the model settings, like stress combination method for random fatigue and other settings like damage models and all. So you can set through the fatigue solution settings. And then you can select which are the parts to be included, or you can select all the parts for to be evaluated for the fatigue. So under this, we need to set up only the event where you need to link the random response analysis, and it is optional to select the structural load case for this, and you need to specify the time exposure, for this run. So once you have given the run, so you can see in the results like what's the max damage, and you can also see the fatigue life, and you can also see on based on the parts rank which is the most affected, which is most critically damaged. So those parts also you can see here. While giving the run for the random response, it is optional to pick the structural load case, which is for the mean stress calculation. So here you can see the max damage, right? So here, once you saw the max damage, you can rectify the design as you know where the actually the it is failing, the structure is failing, right? So you can modify the design and then you can get the new design as a new design study under the in the Simsolid, and you can solve starting from the stiffness evaluation till the fatigue to check on whether the damage is rectified or not. Okay, so this is how you can perform the fatigue simulation for the structures. So till now we saw on the how to evaluate the fatigue on the structure side, right? So let us move on to the what we have for the weld under the welds. Okay, so for the weld we have spot weld. You can do spot weld fatigue or seam weld fatigue, right? So under spot weld fatigue, it uses RUPP method. So this basically examines the weld at three distinct locations. That is the two sheets and then the nugget, which is connecting the two sheets, right? So the cross-section forces and moments at these sheets and nuggets are used to calculate the corresponding stresses. So which are in turn are used to calculate the fatigue damage. So when we do this spot weld fatigue, we get the in the tabular form for all the spot welds, the fatigue damage and the what's the life for each spot welds. Okay, and for the seam weld, it uses Olvo method, which uses linearized stress through the thickness at weld toes, to calculate the fatigue damage. So this method typically requires bending SN curve and the membrane SN curve. So it requires the two SN curves, which can be created as I shown by any of the three methods, right? Either from UTS or through the one slope or two slope methods. So even in this, you will get the results in the tabular form. For each weld, you can evaluate what's the damage occurring, and even you can plot uh, along the weld how the damage is happening. Okay, so let us have a quick demo on this one of the weld. So I'm going with the seam weld fatigue. So for this, I have taken instead of full frame, I have taken the subframe model for showcasing this. So for this, we already have one load case created for this, and it has a bunch of seam welds already created in this model. So you can see the green are the seam welds which I have already created, and we have already applied the material for the seam welds. And this is the load case, or linear structural load case, which we have created for this subframe. And we're just reviewing the results for this. And then we are updating the material properties. As we are doing the seam weld fatigue, we need to have membrane stress life curve and also the bending stress life curve. So that's what we are defining by using estimate from UTS approach. So once we are done with the material, we are going for the SN time fatigue simulation. So in this, we can go either with combinedly weld and also structural fatigue simulation, or you can exclude all the structural parts and include only seam welds for the fatigue evaluation. Here in the fatigue solution settings, you can select the model method and other stress combination methods and the other factors you can specify over here, and even the materials you can check over here. And then you can, like we have done for SN time before on the structural, here we can import the channels in terms of time versus amplitude factor. So for this, we have three curves. There is two curves plus one where Simsolid automatically imports the uniform curve along with the other curves. Okay. So this channel will be used for linking the load case, right, and also the scale factors of each channel. So we are adding the channels and linking that to load case, and we can change the channel scales as well. And you can add the event repeats, like how many repeats you want to perform for this load histories. And then we can directly go for only one time event, or you can create more than one time event as well. So here I have taken two time events for this simulation. So let us see on the for this setup how to post process the seam weld fatigue evaluation. So you can see under the seam weld fatigue results, so it has given in the tabular form. So it is showing the total, means as we have taken two events, right? So it is taking the total of the combined event 1 and 2, okay, and it is showcasing the results for the damage. And you can see for each weld I can select, and you can see on the screen where exactly the weld is. The same way you can see for the life. So now we are seeing for the total combinedly, right? So you can also review the each time event. Okay, so what is the life, what is the damage occurring, and you can also plot damage along the weld length. So this how you can post process the seam weld results. Okay, so now it's 4:25, so it's time for the quick poll. Okay, so I think it's for 30 seconds. So once we have done with that, so we can continue with the slides. Swapnil, over to you. Swapnil. Till now we saw the structural fatigue evaluations and also one demo on the seam weld fatigue. So this is how you can post process seam weld results. And just want to have one point on this. In the under seam weld fatigue, it uses three stress combination methods, including the critical plane, normal stress, and absolute maximum principal stress. Okay, so this is a brief and quick demo on the fatigue simulations. So we have seen today on the mostly on the high cycle fatigue, that is SN life approach. So the process or steps are same when even if you go for the low cycle fatigue. So we have seen the types of SN time or sequential and random analysis, and one on seam weld fatigue simulations, right? So this is just to summarize. And we do have the e-learning material on the Simsolid introductions, where you can quickly learn the tool. Even we do conduct every month, global technical team conducts the training for the Simsolid. So you can register in this. Okay. And yeah, next week we'll be having the next session on the how can we leverage Simsolid for the linear dynamics and the thermal analysis. Okay, so these on August 2nd, same time. Okay, so thank you so much for the for joining, and let us know if you want to know more on this. We will get back to you. Okay, so if you have any queries, and if you have put on the chat window, we will respond for your queries. If not now, then we will respond through the mail. Okay, and we'll send you the update. Thank you so much for joining.